So now that we know how to do both confidence intervals and hypothesis testing by hand, I want to show you how you can skip all of that and do this in StatCrunch. So of course, if I'm working in my stat lab and they ask me to do calculations, this is the quickest, most efficient way to do it. So there are really two options when we do confidence intervals or hypothesis testing in StatCrunch. You're either going to get a question where you already are given the mean and the standard deviation. So here I'm using our basketball scores data, which actually was raw data. I'm just going to use those two values that I had computed earlier. So if I have the statistics, then I'm going to use that. If I have the data, it's always better to use the data rather than to summarize the statistics. But either way, I'm going to go to stat. And in this case, remember we're using T, so I'm going to go to T stats and of course one sample. And in this case, because I'm dealing with those summary statistics, I'm going to say with summary. So here my sample mean was the 57.8. My sample standard deviation was 6.015. And my sample size was 10 because there were 10 scores. I'm going to first do a confidence interval, and we're going to choose a confidence level of 0.9. And again, then just compute. So these are the values that I get, and those matched up with the values that I found before for the mean score for the high school basketball teams. Now, if I want to do the exact same thing, but now for a hypothesis test, I'm just going to go back into my options since my values are already in there. And I'm going to click on hypothesis test. Again, sample mean, sample standard deviation, sample size, and my null hypothesis was that the mean was 55 points, and the alternative was that it was not 55, so it was different than 55. So again, I would just select that from the drop-down and then compute, and then I would get the same p-value that I got previously. It gives me the t statistic, the test statistic, 1.472, etc. And of course, all of those match up with what I did previously. If they actually give you the data, it's always preferable to enter the data. So notice here, I've entered the basketball scores into my first column. So I'm going to do the exact same thing. I'm going to go to stat and then t-stats, one sample, but now I'm going to say with data, and I'm using variable 1 because that's where I have this data. And then same thing as before, if I'm going to do a confidence interval for 90%, then I'll compute, and I should get those exact same values. If I want to instead do a hypothesis test, I would click hypothesis test for 55, not equal to, and compute. So it's very easy to do either one of those. Again, if you're given the data, you're going to want to actually use the data rather than summarize, because otherwise we're rounding statistics and then using those to make decisions. So I would like for you to go ahead and enter the data that we used for our battery. So I have them here. Press pause, go ahead and open up your StatCrunch and enter those values in and see if you can check the 95% confidence interval and the test that we did for this particular question. Then press play to check your work. So again, if I'm interpreting the 95% confidence interval and testing the claim, then I'm going to go to stat, t-stats, one sample. I've got data, and notice I have those in my var2, because it's the second variable. And I'm going to check my hypothesis, which was that it was equal to 300, and the alternative was that it was exceeding 300. So I'm going to compute. Here I'm actually going to do it twice because I want to see them both on the same page. So I'm going to go to stat, t-stats, one sample with data, and then again var2, and this time a confidence interval of 95, and compute. So here's both of my results. So if I were doing, say, a case study, I would do exactly this and take a screenshot of both of those. And notice those match up with what I have here on the screen. And this is just the exact same conclusion that I'd written before. The p-value is high, so we're failing to reject the null. There's not strong evidence that it's that the mean lifespan exceeds 300. We're 95% confident that the true mean lifespan falls within this interval, and of course 300 is in the interval, and therefore it supports our conclusion.